Greetings, everyone. This is Jeff Wilkerson, Professor of Physics at Luther College, bringing you to the next in our series of what to look for in the night sky. We're talking about the week of October 28th this time around. We're going to roll right into November. We got a great fall sky. So this is a week. You know, I've got a board full of stuff I've already worked through here, so it looks messy. We'll try to walk through it again, but and make it clear. But this is a week where we've got almost no moonlight. Very early in the week, very early in the morning, you can see a little bit of moon looking east, but that's it. The moon is between us and the sun, making a new moon pretty much all week, just barely away from the sun. Really hard for us to see. So this is a week where, you know, I often complain. I bemoan the moon. I'm like, it's washing out all the stuff we want to see. We want to see galaxies, and we want to see nebulae, and we want to see clusters, and we want to see all this stuff. And the moon is out there just brightening the sky so we can't see it. And that forces us to look at planets and brighter objects like that, double stars, and we do that kind of stuff, and it's great fun. But I say, we're forced into it. But now we have a week where we go and observe anything we want to, and it's almost like the world's too wide open. I'm like, I don't know what we should observe. I don't know what we should do. But let's start here. Let's stay with the planets. We've been enjoying watching the planets, and Jupiter is going to be coming up here pretty early after dark now. It gets dark pretty early, but you know, by, 9 o'clock, Jupiter should be well above the horizon, probably before that. And Jupiter sits above Orion. And here's Orion, 2 shoulder stars and 2 leg stars and the 3 stars in the belt of Orion. You've heard me complain before about the fact that I can't draw Orion. I can't draw things that are the patterns that I know the most well are the hardest for me to draw in the sky. I can't draw anything, but that's okay. And to say, okay, Betelgeuse is here, this bright red star. Rigel's the bright white star down below. The other shoulder star is Bellatrix. And Bellatrix is this white star. It's a bright star at 1.7 magnitude. Not nearly as bright as Betelgeuse or Rigel, but bright. And if you go straight north from Bellatrix, you're going to come to Elnath. And you've heard us talk about Elnath before. Elnath, if you think about Taurus as a big V like that, Elnath is the top star, the end star in the top rung of that V, the top leg of the V. But it's also about 1.7 magnitude. They're both a little bit brighter than that. They're both really closer to 1.65. So you see these 2 bright white stars, and they're the brightest objects around here. Aldebaran is orange over here and very bright, but they're the brightest stars around here except for Jupiter. Jupiter's big and bright along the way. So as you draw that line, Jupiter's going to be just to the west of that line, and Jupiter is in retrograde motion. We've talked about this before too. It's moving west against the background stars. Usually the planets move east against the background stars, but as we catch and pass them, they turn around and they move west. And Jupiter's doing that right now. Now, last week we talked about Saturn and measuring the motion of Saturn, also in retrograde motion, measuring the motion of Saturn against a faint companion star. It was near over in Aquarius, but now Jupiter here in Taurus is also sitting next to a faint star, but not as faint. It's 109 Tauri is a 5th magnitude star. You should be able to see a 5th magnitude star if you got a good dark sky without any optical aid. Binoculars will really pull it out. The trouble with seeing it here, of course, is that it's got this big, bright object right next to it, and the light of that object is washing it out, makes it hard to see. Jupiter starts the week just 1/3 of a degree. Remember, your finger at arm's length is 1 degree, and Jupiter starts just 1/3 of a degree away from 109 Tauri, and it ends the week as Jupiter's retrograding through Taurus off to the west. It's opening distance right here. It goes from 1/3 of a degree to 3/4 of a degree. So it opens that gap up more than a factor of 3. So that should be very, very noticeable this week. Now Mars, over on the other side of the sky, you got Castor and Pollux here, the twin stars. So you go from Betelgeuse up this direction to Castor and Pollux, and just below there, we were looking at Mars last week. The moon came through here and made a beautiful grouping with these objects. But Mars is in prograde motion this direction across the sky. Mars is going to start the week just barely out of alignment. If you draw a line from Castor and Pollux down through here, Mars is going to be just to the west of that line. It will be noticeably to the east of that line by the end of the week. So Mars is moving faster than Jupiter against the background star. That's one of the fun things you can observe this week, is how much Mars is moving there. Mars is big and bright and red. This is 3 beautiful bright objects right there. But you'll start with a little bit of a kink in that line this direction and end with a kink in the line the other direction as you try to connect Castor to Pollux, and Mars moves across there. Now, if we take Mars later in the week, say right there, and we go from Pollux, I've drawn on this so much it's really hard to see, right? We go from Pollux down to Mars, and they go a little bit more than that distance up this direction. We come to M44, the Beehive cluster. This is a big, beautiful open star cluster in the heart of Cancer. If you have a really dark sky, you can see it. You don't need binoculars. You don't need a telescope. You can walk outside and you can see the Beehive cluster. In binoculars, it really pops out. And so we find the Beehive cluster. Now, one of the things we know about the clusters, open star clusters live in the disk of our galaxy. They live in the plane of our galaxy like this. And the plane of our galaxy, the disks of spiral galaxies have lots of free dust and gas that allow new stars to form. So open star clusters are forming all of the time, which means they could have any age you want. You can have young open star clusters, old open star clusters, but all of that's relative. And we can think about that. We look at 700 million years old. Maybe that sounds old to us, right? We look at that and we say, the Beehive cluster, 700 million years old. Beautiful cluster to look at. We can appreciate it just for being a beautiful cluster to look at. But we can also think, yeah, that was born 700 million years ago. Pretty old. If we go from Mars to the Beehive cluster and make a hard left turn, a 90-degree turn, and drop down a little greater distance, we come to M67. M67 is a fainter cluster and harder to see. A telescope's going to help you out here. If you have it's the smallest of telescopes will do. Binoculars, you can probably see it, but it's not going to be very distinct. Okay? But it's a good open star cluster to observe, and it is 5 billion years old. So it's older than the Earth, or about the age of the Earth. It could be a little bit younger than that. So it could be about the age of the Earth. It's about, what is that, 7 times older than the Beehive cluster, and it makes the Beehive cluster seem pretty young. Okay, so we look at that and we say, well, that's a pretty young cluster now, because we got this big old cluster, the faint stars in here, but lots of them. Okay, great. Let's go back the other direction, though. We start at Betelgeuse, and we draw a line up to Mars, and as we draw a line up to Mars, we pass a relatively bright star, 1.9 magnitude. That's a good bright star. It's the gamma star in Gemini, Alhena. Okay, so we see that maybe, I don't know, what is that, 30% of the way to Mars, up that direction. We get to Alhena, and it's a 1.9 magnitude. It's fainter than Bellatrix, and it's fainter than Elnath, but still pretty bright. If we drop down from there, just a little way, several degrees, half a fist width or a fist width, we drop down below Alhena, we come to the star cluster NGC 2264. 2264, then we can drop about that same distance on down to NGC 2244. One way to find these also would be to say, go from Betelgeuse, the big red star, shoulder star in Orion, and go over to the next really big bright star you come to as you start more or less track straight across the sky to the west. There you come to Procyon. And Procyon in Canis Minor. Big bright star. 2264 and 2244 split that line. One's above, one's below. But all of these are, so all of these are down toward, find Alhena. You drop down toward the line that connects Betelgeuse to Procyon and look for those star clusters. Those are fainter star clusters. Those aren't as bright as the other clusters that we were looking at. And you're going to need a telescope to want to see these star clusters. But what's fun about these star clusters is they're each less than 5 million years old, which suddenly makes the 700 million years of the Beehive cluster seem really old, and it seemed really young compared to M67. So the very young clusters are fun to look at and observe and to think about the range of ages of the open star clusters we're seeing here right now. Now, these star clusters form, we have a cloud of gas and something happens, maybe a supernova hits it, a shock wave from a supernova, but something happens and it causes gravity to overcome the outward gas pressure and collapse starts. And so all of these stars, we love open star clusters because all of the stars were born out of the same cloud of gas at the same time, meaning they had the same chemical start. You have the same mix of chemical elements in there, and they're all the same age. And so you look at them and you say, oh, it's something else. It's not age that's driving the evolution of these stars. You look at two stars just out in the sky, and you don't know which one's older, you don't know which one's younger. You don't know what their chemical start was necessarily. You got to work hard to try to figure that stuff out. Here, you got all that figured out for you. It's all locked in the same. And so right, the process of science. If you've got something that depends on 6 different variables, you've got to hold 5 of those variables constant and then test one variable at a time to see how it varies, how the outcome varies on each variable. Then you hold the other variable and constant and tweak another variable and keep doing that. Here, the chemical composition and the age have been locked out because they're the same for all of these stars. And what we find out is high mass stars evolve a lot faster than low mass stars. So these are laboratories for stellar evolution. They're great. And so you think about those things forming from the collapse of that cloud of gas, and you think about this age range. But what's beautiful about 2264 and 2244 NGC is that these are young enough clusters, you can still see the glow of that cloud of gas they were born from. We call that nebula, right? An indistinct cloud of gas is a nebula in the sky, and we can see nebulosity around these. The Cone Nebula and the Rosette Nebula are associated with these. So if you've got a little bit bigger telescope that you're observing this with, and you got good dark skies and you're patient, you can see the nebulosity associated with these star clusters. That is the cocoon from which they were born right there. So that's what we got. We got some great open star clusters. It's just beautiful to look at, but also fun to think about the ages and to see the environment in which they were born right there. We got a lot of bright stars. We got Jupiter and we got Mars moving against the background stars, and we can track that motion this week. And it should be a good week of observing. As always, everybody, thanks for watching, and we hope you have a great week ahead.